So we saw that we can induce an EMF by making some kind of rotation, right? We take a coil, rotate it in between a magnet, and there is EMF induced. Now let's look at the mathematical aspect of this. Okay. So the basic idea over here is that induction happens when we change how much magnetic field lines are passing via the area enclosed by the loop of wire. So basically varying the direction of the area vector also leads to the same phenomena. So let me show this. What I have here is the coil, right? Same as this. Then this would be your axis of rotation. That's where your rod like structure is passing through. Let me show that again. So basically a stick which has gone through the loop, you know, holding it from left to right. That's what I'm using to rotate it. That's your axis of rotation. That's how I'm rotating it, right? That's your axis of rotation. So that being the axis of rotation, PQRS in your diagram being the coil, B being your magnetic field, what happens? Let's have a look from the side. So this is our side view. Say this is our coil. I'll represent it with just a single straight line. That is your axis of rotation. Axis of rotation. Now we have to, whenever we analyze anything, we have to look at the area vector. So that's your area vector. Here in this case, the angle between the magnetic field line and the area vector is 0. Now say it rotates a bit in something like this, a bit to the right. What happens to the area vector? Yes, it too rotates, because area vector is always perpendicular to the surface, is it not? So now we can see the angle between the area vector and the magnetic field line are not the same. Okay, so it's something like this. So this is theta. So here theta is not equal to 0 degree. Does it make sense? So the number of field lines passing through will reduce. So you can see that it starts to reduce. To be honest, the length should not be that much. It will be something like this. Clearly it has reduced. So whenever we see a changing flux, what can we tell? There will be a induced EMF. That's all. Now we are trying to look at the math. So for that, you guys need to draw this diagram. We'll come back to the graph. So here I've shown the magnetic field line, then initial and second scenario of a coil moved by an angle of theta. So if you guys are confused, this theta has to do with the coil rotating. Just trying to tell that the coil is rotated by theta. And so the area vector has also rotated by theta. Or you guys, if you find that confusing, you can draw this also. Both are right. Okay, let's go to the math. So we'll consider a coil that is free to rotate in a uniform magnetic field B. The axis of rotation is always perpendicular to the field. So we don't have to think about three-dimensional motion and all of that. It is three-dimensional motion, but we can represent with the plane. Now, Faraday, he talks about you can induce a magnetic field. Sorry, you can induce a voltage by by changing the rate at which the flux is changing. And we know that it's always opposite effect. He'll try to oppose whatever is causing it. And that's why the negative. But we know that flux is given by, well, magnetic field line, since it's magnetic flux, BA cos theta, dot product. Now, let's substitute phi in our EMF. This will be minus d by dt BA cos theta. But here BA is constant, so we have minus BA out. While what is changing with time? Angle is changing with time, so cos theta will have to get differentiated. Reason being BA is fixed. And so when I differentiate this, I'll get BA sine theta. Differentiation of cos theta is sine theta. Or is it minus cot theta? No, it is sine theta itself. Yes, this is for a single loop. For n loops, what happens? Yes, all of them will add up. So basically minus n BA sine theta. Okay, so but the answer is not yet done. See, we need to express in terms of how fast am I rotating. So theta per se is okay, but theta itself is dependent on something, right? It's an angular velocity in this case because it's changing with time. In some sense, it is changing with time. So it is related to angular velocity. That's what I meant. So we need to relate that. So herein we'll relate that. Okay, yes, just a second. Some space will help. Yeah, let's look at that. Let's look at theta's dependency on angular velocity. If a coil rotates with an angular velocity theta, while theta is varying with respect to time, how can we express this as theta is equal to omega t? Right? Yes, theta is equal to omega t. And then your magnetic field line, EMF will be given by sine of omega t as a function of time. For omega fixed, it will be just dependent on time. And then let's express in terms of frequency. Omega can be expressed as 2 pi f. And so we have this to be MBA sine 2 pi f t. Okay, so higher the frequency, higher the EMF induced. Makes sense. So higher the frequency, higher the EMF. That's it. Right? Now let's look at the graph. So this is 0, say this is pi, and this is 2 pi. So obviously this is pi by 2, then pi plus pi by 2. So the maths tell us that since theta here is along the x-axis and this is your EMF, so we have the expression. What is the expression? Minus BA and some constant. All these are constant. Sine theta. Let's stick to this. So when theta is 0, the output is 0. When theta is 90 degree, it's maximum. When it's pi, it is minimum. When it's minus 270, sorry, not minus, or minus 90, yes, that is also a possibility. It is minus of 1. Okay, so we'll take this as magnitude. Technically, should be magnitude now. And then the wave will be in that manner though. So it is ulta, my bad. So it would be so and so. So the wave will be in something like this. You guys agree? This is your maximum. Again, in terms of magnitude, this is maximum. And direction wise, these are opposite. So here, what are we looking at? We are varying theta. When theta is 0, it will be 0. When theta is 90 degree, it will be maximum. Sine theta is maximum. But E will be negative B N A. So negative will be represented in the negative, right? So we can call it as E naught. That's your E naught, where E naught is, if I take E naught to be BAN, so your E will be minus, it's not E actually, but anyways, E naught sine of theta. Voltage is equal to minus times of maximum voltage sine of theta. So that would be your graph. Quite simple math. The same concept again and again. The very first video, the same discussion is continuing everywhere. Changing flux.